Hello class, in today's video we're going to be going over modeling compound interest using recursive relations. The learning intention of this video is we're going to have an introductory in the understanding of what geometric sequences are, and lastly we're going to be able to represent and model compound interest problems using recursive relations. Similar to simple interest, there are two ways that we could actually express the balance of an investment that earns compound interest. So similarly to simple interest, you could do this using recursive relations, which is, remember, the long way method. Recursive meaning it's repeated, so you're going to have to add on or repeat certain steps to get your final answer. And lastly, you could also do this using the explicit formula, and this was done in the last lesson. So in the last lesson I would have shown you the compound interest formula, and you were going through several examples of how you could actually apply that particular formula. The main intentions of this video is we're just going to be looking at how do we actually represent this using the recursive relations. But before I do that, I do want to quickly go through again what is the differences between simple interest versus compound interest. So if you look at the diagram below, notice that for every single year, you're going to be earning the exact same amount of interest. So you're always going to be earning a flat rate of $50 per year, whereas compound interest is a bit different because the amount of interest, it gets reinvested, and that interest also earns interest on top, which is why the amount of interest per year always increases, as you can see over here. Now, if you look on the right-hand side, I said since the amount of interest earned in each successive year for compound interest is different, or it's not constant, this means that it doesn't actually follow the similar pattern which you would generally see in an arithmetic sequence, okay? So if I was just to write the terms or the final amount of each year, this is what it'll look like. We know that simple interest follows like an arithmetic sequence kind of pattern because it has the same common difference. So in this example over here, the common difference is 50 because you're always going to be earning 50. So I can kind of guess what the other values are in the sequence. Whereas for compound interest, this doesn't follow the same trend. So there is no static common difference at all. And because of that, this actually follows something referred to as a geometric sequence, okay? And a geometric sequence is characterized by where the next term increases by the exact same rate or the exact same percentage in this case over here. This is referred to as a geometric. And you're going to learn more about this in the following years, especially in year 12. Now, as you can see here, because it doesn't actually follow the arithmetic sequence pattern at all, we actually have a different general formula to actually represent compound interest in this case. So all compound interest problems can be represented by the following recursion equation over here. The main difference is that instead of actually adding it, we're actually multiplying this instead, okay? So please copy this down inside your exercise book. And again, the main thing that you need to note is that this R over here is the interest rate, but that is always going to be expressed as a percentage. Now, if I'm just going to show you side by side the main differences between the recursive equation for simple interest versus compound interest. As I said earlier on, the main difference is that for a simple interest, you're going to be adding the common difference, or D, every single time. Whereas for compound interest, what you're doing instead is you're going to be multiplying. So this is just the main differences between these two recursive equations over here. So let's look at an example so you have a better understanding. So in our first example today, it says the following recursive relation can be used to model a compound interest investment of $1,000 paying interest at the rate of 8% per annum. Okay, and they've already given you the recursive relations. In the recursive relation, Vn represents the value of the investments after n years, okay? Part A reads, use the recursive relation to find the value of the investment after 1, 2, and 3 years. Now, before I even answer this question, I'm just going to quickly go, how do they actually obtain this recursive relation equation? So in this case, V0, remember, represents your principal. So that's this amount over here. And the way that they obtained 1.08, because you need to know how they got this formula, is that remember, you have to multiply your Vn by R, and to calculate R, that was 1 plus the interest rate over 100. In this case, the interest rate was 8. So if you go 1 plus 8 over 100, this gives you 1.08, and that's the reason why they've kind of multiplied that by a Vn. All right, so now let's just finally answer part A. So for part A, if you wanted to calculate the amount in after the first year, you need to know the initial amount. So therefore it would be V1 is equal to 1.08 times V0, whatever V0 is equal to. So V0 in this case is equal to $1,000. So if you put this into a calculator, you're going to get $1,080. Do the same thing for V2. So V2, if you want to find out V2, you're going to have to multiply the 1.08 by V1. So if you do this, 1.88 multiplied by $1,080 is going to equal to $1,166.40. And do the same thing to obtain V3. That's a typo here. That should be a V3. And therefore, that should be your answer. Now, part B reads, when will the investment first exceed $1,500 in value? So in order to do this, you're pretty much going to have to repeat this process until you're going to see a value that's larger than 1,500. So in this case, I've already done that. So in this case, notice that if you keep on going, you'll notice that after the 6th year, in this case, the amount is going to be larger than 1,500. So the answer is after 6 years in this case. What I'd like you to do now is I'd like you to have an attempt at answering this question over here. So if you please follow the exact same example from beforehand, you should be able to get this answer correct. So give yourself 5 minutes or so and then compare your answer with my answer. Alright guys, if you guys done this successfully, okay, this is what you should have got. So again, V1 is equal to 1.063 multiplied by V0. Put this to a calculator. You should get an answer of $21,260. Do the same thing for V2 as well as V3. Now, to get the answer for part B reads, determine how many years it takes for the value of the loan to first exceed $30,000. So again, just keep on repeating this process. And if you did this successfully, you should get an answer of after 7 years. And if you were to kind of like prove this, if you were doing this exact same step, V7 in this case would be 1.063 multiplied by V6. And if you found out what V6 is, then V6 is going to equal to $28,855.57. And if you multiply this, notice how this value now exceeds $30,000, which is why 7 years is the answer. And lastly, for part C wants you to write down a recursive relation. So write down an equation, something similar to this over here, to model when you have an initial loan of $18,000. So in this case, your V0 is going to equal to 18,000. We therefore need to find out what the value of R is. So in this case, the interest rate is 9.4. 1 plus 9.4 divided by 100 is going to equal to 1.045. And therefore, that's a typo. It should be equal to 1.094, and therefore this should be equal to Vn plus 1 is equal to 1.094 multiplied by Vn. We're going to go through another example because this example is slightly different compared to the first example, particularly for part B. And I really want to show you this because many questions in VC often confuse you at part B. So the question reads, Brian borrows $5,000 from a bank. He will pay interest at the rate of 4.5% per annum. Let Vn be the value of the loan after n compounding periods. Write down a recursive relation to model the value of Brian's loan if interest is compounded yearly as well as quarterly. Now I'm just gonna just highlight this over here because that's what I'm trying to do. I'm trying to find out the equation in this case, and notice that I've also included the general equation just for us to refer to so that we can actually answer this question. Okay. Now again, we're trying to write down the relation. So in this case, I need to state what the value of V0 is going to be. In this case, V0 is going to equal to 5,000. So V0 is equal to 5,000, and I've also stated what my Vn represents in this case because you have to actually do this when you have different compounding frequencies. I've got to mention that earlier on. So now what I'll do is I'm going to find out what the value of R is going to be. So R in this case is going to be 4.5 divided by 100. So therefore my R is going to equal to 1.0045. Substitute this in. So therefore this over here is going to be your final answer when you're writing down the recursive relations. Now, how is this different for part B? Now, because you're being compounded quarterly, your Vn now represents the value of the loan after n quarters or so. And we know that in a year, there are 4 quarters, okay? So, again, your V0 is going to be exactly the same, but your R, your interest rate, is going to be a bit different. Usually, as you can see over here, this represents the interest rate for the whole year, which is why it says per annum. You're doing it per quarter, okay? And because it's per quarter, you actually have to divide this by 4 because this, if you multiply by 4.5, that gives you the interest rate for the entire year. But since you're trying to find out the value after n quarters, you need to divide it by 4 since there's 4 quarters, okay? So as you can see over here, I put this in brackets and I've actually divided that by 4. And as you can see over here, my interest rate is going to be a bit different. My R is now going to be 1.01125. So therefore, this is going to be my final answer. So if you do encounter a question that even says monthly, okay, so when it's monthly, it's going to be a bit different. It's going to therefore be dividing it by 12 since there are 12 months within a year. Biannually would be the same thing since there's biannually is 2 times, therefore you divide by 2, okay? Okay class, what I'd like you to do now is I want you to have an attempt at this question over here. So if you guys just please follow the example that I've shown you just beforehand, you should be able to get this question correctly. But again, the only thing I want you to be wary of is that in this case over here, it is being compounded quarterly, okay guys? And when you do answer part B where it says, if Jessica pays back everything she owes to the bank after 1 year, how much money will she need to pay? So just consider, are you actually trying to find out what V1 is, V2, V3, or what is it that corresponds to 1 year? So give yourself 5 minutes and then compare your answer with my answer, okay? So again, if you're doing part A, you're trying to write the recurrence relationship. So in this case over here, you need to state what your principal is going to be, and then you just need to find what the interest rate is going to be, okay? But again, what you need to do, because you're trying, it is compounded quarterly, you do need to actually divide this by 4 since there are 4 quarters within the year itself. So if you did this correctly, you should get 1.02, and therefore just multiply VN by 1.02. Now guys, for part B, because you're trying to find it after 1 year, technically what you're trying to find is the value of V4, okay? So that's the value of V4 will tell you how much money that Jessica has to owe back after 1 year. Since in this case, VN represents the value after the first quarter, so that means after 3 months. So therefore, find out what V1 is equal to. V1 in this case is going to equal to 3,570, okay? And then we need to do the same thing to find out the V2, which gives you the balance after half a year. So do this, that will give you $3,641.40. Do the same thing for V3 as well as V4, and therefore you should get this over here as your final answer, guys. Alright guys, what I'd like you to do now is I only want you to answer these 2 questions for today's lesson. And if you guys did this successfully, then this is the answer that you guys should be getting for these 2 questions, okay? This is the end of today's video. Hopefully this video helped you out. I'll see you guys again in the next video. Bye.